Everyone, Radhe Radhe. Right, so I think it is our eighth live uh, right now. We'll try to we'll try to have some detailed, some detailed overview of the concurrency part of Golang as well, as we have, you know, um, will be continuing as per our last live for now, in which we discussed about the concurrency part of Golang, and now also as well we'll try to cover some of the components of concurrency that has been handled in Golang through the Go routines, with threads, channels, mutex, select statement, and a lot of other things as well. We'll be diving deep into the whole abstraction layer, like the lowest layer of abstraction layer, but it's not a single live stream for covering the whole part of it. We'll try to go over the whole concurrency layer or the abstraction layer, the lowest layer of abstraction as well, with the Go routine, diving into the OS threads and the operating systems knowledge as well. But it will go on with some other, lives as well. It won't just go along with a single one. Okay. Let me just check my mobile as well. Just have a look if everything's been going on all fine, so that I can just have a quick glance if there's any particular kind of problem in any streaming, then I can just have a look and look over the problem as well. Fine. It's all fine as for now. Alright, great. So let's open up our doc as well, Google Docs. For any particular person who just want to access the Google Docs, where we usually put the summary of the whole live session, I have just dropped the link in the description as well for accessing that Google Docs. Right, so here it is, and live list. Let me share my screen. Okay. Fine. So as in our last part, we discussed, we have a quick overview with the documentation of Go as well, and also the concurrency part of Go, where we like it is for the book Concurrency with Go book that has been written by the Cox, I guess. I didn't have a printout as well of that book, Catherine Cox. Yeah, you have to shout out to her as well. It has been published along with the OLE, so that's why if any particular person really want to have a really detailed look over the whole book, then you can just go over there as well. Edition board. Right, so let's see if that's right. Someone else as well. I mean, add another link. Let me just see if I can see all fine. My internet is down. That is all stable for now, I guess. Fine. Anyone who's joining, just for the reason, comment and ask if they does have any particular kind of doubt as well. for the whole live session and for the whole book or either core and docs, which I will try to review it as well. Right. So, what do we mean by congruency at first? To be honest, it is really important part of the whole software development cycle as well. If my voice all clear for now, um, right. So I'll continue. For any particular person who doesn't know as much about the congruency part or either about the software development as well, well, in software development, we usually have programs that usually works in which it has been proven, but also at the worst level, we find a lot of programs that has been running and they have serialized pattern. One pattern, one like whenever we write code, whether it's Java or either Angular or any other language as well, we might have written the main file, like the function main or either public static void main as well in Java as well as also in C. We just simply call the main function and then just kept on writing the whole code according to the the operating system as well, as well in Java. So whenever we usually want to, call out some functions, and they usually get called out in a certain serialized manner. But whenever we have to, handle a lot of different uh, applications or the real life examples of the real time application that are running over the internet. Let's say in this YouTube as well for now. So already in YouTube, there's a lot of things. There are a lot of different processes that are being taking place all at once in parallel. Like you have been watching a particular stream as well as also you've been liking it, you've been commenting something on that particular stream as well. So all of them, I'm not saying that all of that is being handled with the help of the Golang, but it is a part of the concurrency. That's what I'm saying. So concurrency is a concept in which more than one program, two or more than one program, all those particular programs or the operations usually get handled by a particular software or an application all at once in the most favorable manner. Like as well as also concurrency is really an interesting topic. That's why it is one of the most confusing kind of topic as well because there's not a very nice definition as well for it. In the last that's why I paused in the last stream and just note down the particular definition as well of concurrency. That's why I said by the William Kennedy. Yeah, by the way, he's an amazing author as well. If you want to know more about the goal length, then you can read his book as well. He just defined the concurrency as the out of order execution. If it doesn't have the more resources or either the memory computer is running onto your your local machine, then in that particular case as well, you have to execute certain process as well as operation on your system in a certain way. So that's why it's also that's the main concept behind the concurrency. A lot of people usually confuses or kind of misinterpret the concept um, of the frequency along with the parallelism. Guess reason that might be a bit of a problem. I don't know. I guess it isn't getting overlapped with my own voice, right? Fine. Yeah, fine. Predict. Yeah, it did. Let me just mute it as well, and it will just yeah, fine. Sorry for that. All right. So people usually confuses concurrency along with parallelism. You can understand it in a way that a certain program usually requires a certain amount of CPU as well as also memory in order to run and execute a particular operation. That particular operation might need some kind of CPU as well, say a certain memory threads that has to be accessed and being synchronized, being assigned to that particular operation in order to get executed. When it is a serialized manner, when in particular operation or the program is being executed in a serialized manner, in that particular scenario, just different kind of programs or the operations have been going on or being executed in the serialized manner. All the memory would be allocated to a single particular kind of an operation or the the program that has been taking place, and that's how it actually goes on. There isn't as much of a problem for any particular software engineer at that moment, at that layer or level of software development. But when it comes to the concurrency as well as also the parallelism, in that scenario, the parallelism usually allocates the memory, to a lot of different programs that has been running in parallel. Like uh, if you have 100% of memory that has been provided to the system by the system to your particular program, you are having four different operations that has been running at the moment, and your CPU will just allocate your whole CPU memory or the resources memory. It will just divide the whole of 100% into chunks of equally uh, four parts, that is 25, 25, 25 and 25%. But that is also not as much sustainable, to be honest. And because you might have some other operations as well that might have been running on your system, which is kind of abstracted, so you doesn't know as much about that either. So the best part could be the best way of handling along with the multiple operations of the program that has been running is the concurrency, in which let's say if a program has been running and it has a lot of different operations that's been running on top of it. Any particular operation might need some amount of resource, then you could provide memory to that particular operation of your program in a certain way, such that it won't eat out the whole time of the another operation as well that has been running onto your system, because different operations might take different amount of times, as well as also the memory usages or CPU usage. So that shouldn't interfere um, along with the operation that has to be performed onto some other program. So in that way, concurrency provides us a way in which you could just handle your resources, your CPU resources, as well as also your memory resources, your system's resources in the perfect manner. So that's all about the concurrency, because that's a really important part. That's how the the servers usually goes out of memory. Your computer also might go out of memory if the whole synchronization part or the concurrency part isn't being handled as perfectly. You might have heard about the your CPU has say 12 cores or some threads, 16 cores, or 24 threads, and a lot of other things as well. You might have also heard about that the GPUs usually have thousands of cores, or the threads that has been allocated for performing multiple operations all at once. So that's how the concurrency actually runs around and being performed by different types of CPUs as well as GPUs as well. So in order to handle along with the concurrency, it is very important for any particular kind of a developer as well, in order to understand their systems in the most perfect manner. Like any particular, let's take an example of a doctor. Let's say any particular patient might reach out to a doctor. She will kind of examine what are some of the problems he or she might have been experiencing since a while. They might have been having some kind of dizziness or some kind of fever, so they might go along or start checking, going along with their medical report as well, like their blood test. So blood test might have different kind of results, like the parameters, like either the hemoglobin is kind of really low, or either the lipid profile, including the diabetes, or either the whole LDL or HDL or anything else as well. They will kind of track, build up a certain kind of a map into their whole mind, and that's all that has been made only because of that particular whole a, a report that has been provided to the doctor. In the same way, for any particular developer, in order to reach out to a certain conclusion, you will have to go over with everything that has been provided, like by the system, while going along with the logs as well as also the matrices and events that might have happened. And in order to understand them all, you will have to reach out to the lowest level of abstraction. What do we mean by the abstraction? Well, any uh, anyone who's in first year at the computer science degree, they might not know as much about the abstraction at the moment. So certain different, I would say, tools or softwares, they try to hide the not so important kind of information from the user in order to increase the alright, um, in order to provide a better. There's some kind of right, fine. Number is all good. Right, so let me share it again. Right, so we were discussing about the, I think I was explaining about the abstraction. So any particular thing that is not so important for any particular person at any layer, at any level, and you really want to, hide the important details about any particular thing, then you might, kind of just hide them out. And when, we've been using YouTube as well as also Facebook, but at that time you've been using a lot of different, APIs. You've been sending a lot of different APIs in order to get information. You've been sending the get method or the get, function, as an API part to the, the servers of the YouTube. And in order to post any particular thing, I've been using the, live real-time streaming application, that is YouTube. So I might be using some other kind of an API or the streaming REST protocol, or either RPC framework either. So that's a whole thing which is being abstracted out of as general, any particular person who doesn't know as much about these particular things. They can just, click onto some kind of buttons, or some just start speaking out in front of the camera, or either in front of the, the audio as well, your mic as well, without knowing the general things, or the certain things that has been going behind the curtains for the whole show. That's been abstracted out or been hidden in order to save, in order to, perform any kind of the security threats, in order to save themselves from the security threats, or either in order to increase the user experience as well. Because it doesn't need that much amount of information to be provided to you. You just need a certain button or some other kinds of, useful things that has to be presented in front of you for the whole platform or the application, and that's been abstracted out. So that's the whole thing. You will have to go over to the lowest level of abstraction. What will be the lowest level of abstraction? It will provide you as much information, that is as much information or the details about any particular operation that has been going onto your system. So you'll get to know what are different, methods or the functions that has been triggered as soon you clicked any particular kind of a, button, or sent any particular kind of a request or an API endpoint. As soon you have hit any particular kind of an API endpoint, what are some of the, the actions that has been triggered by the application, so that all of those particular things would be shown, would be visible to you at the lowest level of abstraction. That's the whole point of it. So as a software developer, you have to understand about these all things in order to understand the best of, like the best practices that has been required for following the concurrency part as well. So that was the whole thing. And let's kind of go over some of the docs as well by Go. We'll be understanding the whole concepts of concurrency from the, different docs, as well as also from the blogs, or either the various tech talks as well at different conferences that usually occurs around the globe. We'll be taking help with the KubeCon or the CloudCon, or either GopherCon, or a lot of different conferences as well that usually takes place once, or uh, after, frequently they at different places. So you all right, so to perform um, any concurrent application, any concurrent operation that has been performed at the lowest level of abstraction, that is being handled with the help of an OS thread. OS thread handles all of these particular kinds of the operations, provide with memory synchronization as well to all of them, and in order to perform them, you'll need an OS thread. And the memory and during that particular process, the memory access would be provided to the space between all of these particular OS threads. And if you'll say, let's say you asked or requested for a particular kind of an operation to be performed, a concurrent operation to be performed At that time, you will ask your operating system to perform that particular kind of an operation, but your OS doesn't have that much amount of money to be allocated for your operation. So in that scenario, you'll provide or build up a kind of an a pool of an OS threads. So that is an amazing topic. But in Go, we'll try to restrict ourselves to the Go for a moment. We'll try to cover all these particular tools on these concepts as well when we'll try to discuss about the operating systems. And that is other kind of a thing. We'll try to explain different cases as well as different kind of the topics that has been provided to you with the help of the uh, you know while explaining about the goals concept, and also taking care of the OS as well. So OS threads in Go routines in Go language, by the way, is it has been developed by these certain the developers in order to handle the concurrency. It has been revolving around the concept of concurrency. So it isn't kind of Go isn't kind of an immutable from these particular kind of problems either, but it is a lot lesser. There exists a lot lesser friction when it comes to the concurrency or handling different APIs as well, building up your architecture. That's why it's been preferred a lot while you are building an cloud API architecture for your system, or providing certain different powers to the different components of your microservice architecture as well. So that's the whole point of it, and we'll try to go over all of these particular topics. All right, so first one of them is the Go routine. Like we saw while handling different OS threads, there was a lot of different complexities that were being observed at the earlier stage, at the really previous early stage of our whole software development. And that's why while they were building the the Go programming language, they came up with an idea of providing a Go routine. Just wait for a minute, let me just connect my charger. Right, perfect. Let me switch this off and start my own YouTube video. Perfect. Anyone who's present over here, please like the stream as well. Like this whole live stream that's been going on right now, and yeah, comment as well. Okay, so the developers actually came up with an idea of Go routine, building up the certain Go routines which will be allocated to each and every particular OS thread as well. Certain different, modular Go routines will be provided to different each and every particular OS threads in order to for the easy scheduling as well as also easy auto scaling as well for your OS thread in order to handle out the concurrency part of your function as well. So the OS like the OS threads was being replaced with the Go routines, and the mutex part was actually being replaced with the channels. So we'll try to discuss all of these topics. We'll be discussing about the the Go routines, OS threads, channels, mutex, sync, and async, all of those packages as well, lock and unlock, and channels as well, and memory sync, memory synchronization as well. All of these particular topics we'll try to go. Let's just search. By the way, happy new year. So here it is, and let me see if it does have some. Oh, it's some. It's just discussing about different components of Go. Yeah, here it is. Concurrency. Yeah, share by communicating. Concurrency programming is the last topic, and there is space only. Concurrency programming is the last topic, and there is space only for Go specific highlights here. Concurrency programming in many environments is made difficult by the subtleties required to implement correct access to shared memory. Go encourages a different approach in which shared values are passed around on the channels. In fact, never actively shared by separate threads of execution. Oh, one more concept. There are certain different operations that's been going on at the moment, and there are a lot of different codings as well that will be sharing different information as well. You might have used a lot of different functions as well. You might have defined a lot of different functions as well as also a lot of different methods in your programming code. At that time, whenever you pass on a certain function, at that time you pass certain values as well. At that time, a certain block of code has been been that has been called. So that's why certain different context has also been shared whenever you call it. Like from main memory, whenever you will be passing on some kind of values for your variables that has been passed into your arguments. At that time, you'll be sharing the context that has been passed into the block of code that will be using and that you'll be using as the main function, or either at some other function as well that might have been written by you. So that's why is your whole concurrent code will be using a lot of different blocks of code all at once at the concurrent time. So at that time it's really important for you as well, in order so that the memory that has been shared, and the access or the context sharing, that this whole process has been called as the context sharing, and that's why the context sharing has to be made really secure. And in order to make it secure, what is one of the the really uh, I would say recommendable kind of an approach is that you will provide the context sharing to a single user at a concurrent time. I'm not saying that your application or your function could be used only by one particular function, but at a time, whenever an operation has been shared or been used at a time, concurrently it must be used by a single user, so that the multiple different attacks might not happen at the same time, and multiple different frameworks might not use it all at once, so that you might not fall into some kind of a race condition, or either at some kind of a loop or deadlocks kind of a situation. In that scenario, the whole concept of parallelism and the concurrency will kind of collapse together, and it will provide a lot of different difficulties for your environments as well, and for your for your structure, for your code structure. So yeah, that's the whole part of the security. Yeah, so we were discussing about the channels, and I guess they will start sharing about it as well. Community sequential processes, CSP. Go routines. They're called go routines because the existing terms threads, core routines, processes, and so on convey inaccurate connotations. A go routine is a simple method model is a function executing concurrently with the other go routines in the same address space. It is lightweight, costing little more than the allocation of the stack space, and the stacks start small. So they are cheap and grow by allocating, and freeing heat storage are required. Just wait for a minute. All right. Concurrency, share by communicating. Alright, so I was at some other side. Sorry for that. Share by communicating the whole concept, it will be considering, try to it will try to explain about the context sharing and a lot of other things as well. That's why it's been saying that either you can share by communicating, or either you can communicate while sharing. So there are two different kinds of approach. One of them has some of different methods. While you are using like the memory synchronization, at that time you might use some other method, or either when you're using channels, at that time you can use some other method as well. So that's the whole part of it. Share by communicating concurrent program is a large topic, and there is space only for some go specific highlights here. Yep. Concurrent programming is in many environments is made difficult by the subtleties required to implement correct access to shared variables. Go encourages a different approach in which shared values are passed around on channels, and in fact never actively shared by separate threads of execution. That's right. See, they are never they are kind of never shared actively shared by separate threads of execution. They'll be will be used by a single thread, or either by a single go routine at a time, or at a concurrent time, not like for the whole application cycle or the developer cycle. That will be a really messy kind of a situation because you'll need to use function multiple times in the whole for the execution of the whole operation. That's why you can, like for minute concurrent time, you'll be using it by for a single thread, or either for a single go routine at that time. Only one go routine has access to the value at any given time. Yeah. Data races cannot occur by design. To encourage this way of thinking, we have reduced it to a slogan: do not communicate by sharing, instead share memory by communicating. Yeah. Yeah, that's kind of amazing. Let me just it's yeah, it is kind of remember it, kind of you have to keep this particular kind of line in your mind if you are go developer for any particular environment or the application whichever you've been designing or been developing at the moment. Yeah, so let me just kind of write 7 to 8 because I'm not changing the whole main topic of it either. Name it 10 because the next one would be about Rust. We can take this particular topic as well. I don't know. I really want to take it open telemetry. Um, yeah, just I mean highlights, highlighted format because it is very kind of important. Or else I can reduce it. Yeah, it looks a lot better now. Do not communicate by sharing memory. You shouldn't communicate while sharing memory. Instead, share memory by communicating. All right, perfect. You shouldn't, yeah, like it's been trying, it's trying to say, it's trying to emphasize upon the whole concept that you shouldn't allocate the memory access or the context sharing to a lot of different processes that might have been occurring all at the same time. At a concurrent time, you should share it only to a single go routine, or either to a single thread. And instead of, whenever you want to share memory at that time, you shouldn't communicate by sharing memory. Instead, you just share memory by communicating. You just use a single uh, function or a single go routine at a moment, and then you can use its output that has been captured or been returned to you into the main function, and then use that particular information to be used at some other the functions as well. That might make a lot more sense instead of the other route. This approach can be taken too far. Reference counts may be best done by putting a mutex around an integer variable, for instance, but as a high-level approach, using channels to control access make it easier to create correct programs. One way to think about this model is consider a typical single-threaded program running on one CPU. It has no need for synchronization primitives, no run another such instance, it too depends on the synchronizations. Now let those two communicate. If connection is desynchronized, there's no need for the other synchronization using Unix pipelines. For example, like the fit the model perfectly, although Go's approach to concurrent originates in the host communicating sequences, CSPs. It can also be seen as a type generalizer for Unix pipes. They are called coroutines because the existing terms of the threads and coroutines processes and so on convey inaccurate connotations. A coroutine is a simple module. It is a function executing concurrently with the other coroutines in the same address space. It is lightweight, costing a little more than the allocation of stack space, and the stacks start small, so they are cheap and grow by allocating heap storage are required. Oh, if anyone's enjoying the whole live stream as well, they might also um, share the whole or just kind of like uh, or repost the post that I put on my LinkedIn so that more and more people can get to know about it as well. I put it in the links. Let me put it in the live chat because it will be a lot better. Connect with me on the LinkedIn as well if you want to know more. Anything else, if you does have any particular kind of a request as well, I might consider going over them in the future live streams as well. If you have also taught about any particular topic over at any tech talks or either at the conferences or either the cons or even the your local college conferences as well of the tech talks, I might have a review over them as well. Or if you does have any particular kind of a blog or the paper that has been published recently, we might have a look as a whole community as well. It will be a very amazing everything. Right, so let's continue our go routines. They are coroutines because the existing term threads, yeah, these all are a simple model. It is a function executing concurrently along with the other coroutines in the same address space. Yeah, same address space. That means like the memory has been allocated between any two particular OS threads, so that's why it's been running on with the same address space. It is lightweight, costing little more than the allocation of the stack space. Just wait for that. Yeah, perfect. Let's see if I'm. Yeah. Alright, so like Go's runtime usually multiplexes Go routines onto the OS threads automatically and manages scheduling for us as well. So it's a lot better for the scaling as well as scheduling part, and we can optimize to runtime without changing how we model our problems. Like there is a classic separation of the platforms as well, or the problems as well in the whole software cycles. And since it manages the scheduling so efficiently, this can also inspect on the whole Go routines as well, blockage and that has been occurred due to the IO as well, waiting for any IO and intelligently it can also allocate memories to the OS threads or to the Go routines as well. Like in case of any particular kind of a problem, and in that particular scenario, it can intelligently just reallocate the Go routines that has been allocated to a single OS threads in that case, in order to save us from any kind of security vulnerabilities. And since some kind of channels are inherently composable, right? Like let's go over the channel section. Yeah, this and next one is channel. Alright, so the keyword that has been proposed for the Go routines is like just the Go, and then we'll list the same task. that. Right. So it was all about the goal routines. Now for the channels, like maps, channels are allocated with the make sentence. Yeah, like you might be knowing about the maps as well, and the yeah, that I was also taking the example of maps only. So also for producing maps, you'll kind of use the make statement in that scenario as well, or either for the building up of 3D arrays as well, or a lot of different other components as well. In that scenario as well, you might use make, and resulting values acts as reference to an underlying data structure is if an optional integer value is provided, sets the buffer size of the channel. The default has been put to 0 for an unbuffered or synchronized channel. Unbuffered channel combines communication. Yeah, here it is. C and make allocated a channel to the go routine. Start the sort and go signal has been sent to the channel. You can also, all right, so if you want to try the DSA as well, data structures, if you want to practice the DSA in code, in that case also you might come across a particular stage where you want to create the whole trees as well in order to produce the whole architecture, or in order to produce a data structure for your application, like handling the data of the different entry that has been filled. In that particular scenario, you might use trees in order to save it. Like for managing the database, earlier there were multiple kind of like multiple or different kind of database styles in which their information was actually being collected or being saved. One of them was the file system, another one was the tree one as well, and a lot of other things as well. So for them, for building up a tree, Go, you might use channels as well as also Go routines. It might be really an amazing thing, a really good practice for you as a software developer, because you'll be using Go function in order to perform any concurrent function that has been going, that has to be performed, and any return. You'll get some uh, value that will be returned from from our Go routines that we have created, and all those particular values would be stored or being sent as a signal to the channel. And if it comes or being returned a nil statement, a nil kind of a value response from the Go routines, in that scenario, the channel will kind of just get closed, building up the whole tree. So yeah, that's how the whole trees are also being designed or being developed in Go functions. Right. So once max outstanding handlers executing processes anymore will block trying to send into the filled channel buffer until one of the existing handler finishes and receives from the buffers. This design has a problem though. So creates a new routine for every incoming request. Right. So either we can just kind of, right. So I just have to go for some 3 to 4 minutes. Either we can review the codes that has been mentioned on the official docs, or either we can just, I can play a video from the GopherCon about this particular concept of concurrency, handling the concurrencies with the channels or Go routines. It is really kind of a basic concept. So which one we should go? Anyone want to recommend? They can also fill in the comment section, like in the live uh, chat, in the chat section. Whether you want to go with the, oh, I can put a poll, I guess. Yeah, start a poll. Hmm. Right. So I have put a poll right here. Uh, you want to call like vote or all right? Anyone else want to vote for now? Right. We might go over a video, I guess. I can. I mean, kind of resume the last video that we were watching in the last stream, or either we can um, just kind of explore another video. Maybe it could be um, someone else, but still about the concurrency, it could be a bit easier because I'm just explaining about the really easier concepts of concurrency. I just came across the Go routines and a lot of other things. So let's see what do we have. Concurrency made easier. I really want to view it as well, but just wait. Which one we should watch? Either this one or either this. It is Go for Con 2018 and the 2017. Concurrency made easier. I guess it would be a lot better because it might start making a lot more sense because it might start explaining about the Go routines or either about the channels, and it might take all these particular components or in the same at the same year. Right. So perfect. By the way, just sorry for interrupting, but I'll play this video again because I also want to take some more notes to be a bit more clear while talking about the concurrency as well, because it is an amazing topic. I just have the whole understanding as well, but still, I want some straightforward definitions as well for different parts and the components as well of explaining about different components of Go. So I might have to uh, just replay the whole video as well. So, for interrupting, let's start. Okay. And a huge shout out to you guys as well. So, अरे राधे मैं जा रहा हूँ ना तुम भावना is it still audible if I'm kind of just pausing, like stop muting myself? What is oh can anyone help in telling me if if the video is being shown, or have I just now restart it again for making it easier?
And similarly, in my self-appointed role of a developer advocate, when I meet people who've learnt Go, one of the more common things they say after they've been writing Go for a year or so are kind of things like this. I mean, show of hands, does this resonate? Do these quotes resonate with anybody? One person at the back, you're honest? Yeah, okay. Now, if you've learned Go formally, like maybe you've taken a training course or you've studied it in a book, you might have noticed that the concurrency section is usually towards the back. I mean, this is certainly true of my own material. So clearly there's a disconnect between the concurrency primitives that the language offers and the expectations of some, maybe many, who come to the language for exactly those reasons. I mean, there's kind of a dichotomy. The headline feature of Go is our simple, lightweight concurrency model. And as a product, like, the language really sells itself on this alone. But on the other hand, we have this narrative that concurrency isn't actually as easy to use as we make out. I mean, otherwise, authors and trainers wouldn't make it the last chapter in the book. And we wouldn't look back on our formative efforts, perhaps with regret. And this is kind of a shame, because I believe that the Go concurrency model is available. And more importantly, the requirement for parallelism available in our hardware has never really been more acute than it is now. So with this as a background, I want to spend my time today talking about some ideas that could make concurrency easier to use, not just for newcomers, but perhaps for all of us. So let's start in the obvious place. I mean, we're talking about the Go keyword. Here is our simple 2.0 Hello World program. Show of hands, just yell out. Can anyone spot a problem with it? At the back, yell it out. Never exits, okay, close, yeah. Pardon me? What? Yes, there. This right here. Absolutely, that's right. For is an infinite loop, this empty for loop. So it's going to block the main Go routine because it doesn't do any I/O, doesn't wait on a lock, we don't send or receive on a channel, or otherwise communicate with the scheduler. And as the runtime is, we can say, mostly cooperatively scheduled, this program is going to spin fruitlessly on a single CPU, and maybe it'll end up live locking the program. It could starve the Go routines doing actual work. So how can we fix this? Here's one suggestion. I heard someone laugh down the back. This is quite a common solution I see that people come up with. And I think it's symptomatic of not understanding the underlying problem. Now, if you're a little more experienced with Go, you might write something like this. The empty select here will block forever. I mean, that's a useful property because now we're not spinning a whole CPU just to yield to the scheduler. But as I said before, this is just treating the symptom, not the cause. So I want to present to you a different solution, hopefully one that's occurred to you already. And that is that rather than run listen and serve in a Go routine, leaving us with the problem of what are we going to do with the main Go routine, we simply run listen and serve ourselves. So this is my first suggestion. If your Go routine can't make progress until it gets the result of another, oftentimes it's going to be simpler to just do the work yourself. This often coincides with eliminating a lot of state tracking and channel manipulation that is required to plumb the result from that go routine back to yourself. Now, I've chosen to make this my first example because compared to my next, it's not only shorter, but perhaps it's more profound. Because many Go programmers overuse Go routines, especially when they're starting out. Now, the previous example showed using a Go routine where one wasn't really necessary. But of course, this is Go, and one receives no points for doing only one thing at a time. And indeed, there are many instances where you want to exploit the hardware parallelism you have available to you. And so, to do that, we must use Go routines. Now, in this example, which is taken from a prior version of GB Vendor, we're attempting to fetch a set of dependencies in parallel. So the goal of this restore function is repos represents a set of remote Git repos, effectively. And so we're trying to fetch as many as we can in parallel. Now, give you a minute to look at this code. Does it look reasonable? Can you spot any problems? Show of hands, who thinks it's perfect? Can anyone see a problem with it? Yeah? You want to yell it out? Okay. Read from a closed channel. We'll come back to that. As a code reviewer, one of the first things I'd be drawn to is this interaction between this section here where we're deferring the call to waitGroup.done, and then we're retrieving a value off the semaphore. And in the main Go routine, we're waiting on that wait group to be decremented, and then we're closing the semaphore. Was that what you noticed, or was that something else? Okay. So my question for you is, the close of this sem channel happens after waitGroup.wait. They happen in sequence, so we know that it happens afterwards. We also know that the close of semaphore happens after the call to waitGroup.done, because this statement won't return until all the wait groups have been called done. However, this receive from the sem does not necessarily happen before this. So can the close of sem cause a panic? Yes or no? Who thinks yes, it could cause a panic? A few people. Who thinks no? Even less. So as it happens, no, this can't cause a panic. One of two things will happen. Either the receive from sem happens before the close, in which case the receive from sem drains a value from the channel, and then we mark it as closed, or the close of sem happens first. So, what does receiving from a closed channel return? Anyone? I heard a few people say 0 value. When does it return it? How long does it take? Immediately. Right. Now, the point of talking about this is that, well, it turns out that these two outcomes are both safe. We had to spend some time thinking about it. The logic here in this code is unnecessarily confusing. So if we simplify the defer statement and reorder the operations, we get something like this. Now there's no question in which order the operations are going to occur. In the program, at the top, we add to the wait group, and then each time through the loop, we push a value onto the semaphore. When the go routine is done, we take a value off the semaphore, and we reduce the wait group count. And then in the main go routine, we're just waiting on that wait group count to drop to 0. So now there's no ambiguity what's going on. So the suggestion that I draw from this example is always release locks and semaphores in the reverse order that you took them. At best, mixing up the order, as we saw previously, generates kind of confusing code. We have to think about it. We have to reason through all the possible states. And at worst, mixing acquire and release logic is a sure path to deadlocks. So now we've rearranged the program a little, we can ask another question. What is the reason for closing the semaphore channel? I mean, if a restaurant closes, it doesn't remove anyone seated at the table. It's just an indication that the restaurant isn't taking any new passengers, sorry, any new customers. So similarly, channels are not resources like files and network sockets. The closed signal doesn't free a channel. It just marks that channel as no longer accepting new values. Now, in our example, nothing is waiting in a select or a range loop for that closed signal. So we can just remove the close of semaphore. It's not necessary. So closing a channel is a signal to its receivers that it's no longer accepting new data. Little more. Closing a channel isn't necessary to free a channel. You don't need to close a channel to clean it up. And speaking of semaphores, let's look a bit closer at how SEM is used. So the role of SEM is to make sure that at any one time, there's a cap on the number of fetch operations running. We don't want to start them all at once. We want to gate them. When I gave this talk in Melbourne, I said the number 4 was probably about as much as the Australian internet could take. But if you look closely, SEM isn't guaranteeing that there are no more than 4 fetch operations running. It's actually doing something else. Can anybody spot it? Yes, at the back. Correct. So rather than, can anybody spot it? Yes, at the back. Correct. So rather than guaranteeing there are no more four operations running, it's actually stopping there being any more than 4 Go routines running at one time. So assuming there are enough values in repos, let's just assume that there's quite a few to fetch. Each time through the loop, we're going to try and push the number 1 onto the SEM channel, and then we fire off a fetch Go routine. So what happens when we get to the 5th iteration in this loop? It's quite likely that we'll have 4 Go routines running, or at least have been scheduled to run. There's no guarantee by the scheduler that a Go routine is run immediately or put on a backlog. So there'll be 4 already in train. But on the 5th iteration, the main loop is going to block here before we start the Go routine until there is space on the semaphore channel to push another value. So rather than spawning len of repos number of Go routines and letting them fight it out amongst themselves for a semaphore, this loop is actually going to proceed at the rate at which fetch operations complete. Now, it doesn't matter so much in this example because the whole of restore blocks until we've fetched all of the repos that we need. But there are many situations where the calling code expects to be able to set up this work happening in the background promptly and then return. So the most straightforward solution to me is to move the taking of the semaphore inside the Go routine. So now all the fetch Go routines will be created straight away. We just go through this for loop very quickly, creating those Go routines, and they'll negotiate amongst themselves for a place on the semaphore channel. And so a recommendation from this perhaps could be that although Go routines are cheap to create and schedule, the resources they operate on, files, sockets, bandwidth, disk I/O, are often scarcer. This pattern of using a channel as a semaphore to limit work in progress is quite common. But to make sure that you're not unduly blocking the code trying to offload that work, a good idea is to acquire the semaphore when you're ready to use it, not when you expect to use it. So hopefully we've got all the bugs out of this program. However, there is one more obvious one that I haven't talked about, and it's quite a serious one that I think obviously got all the bugs out of this program.
Let me just
A good
bring them over. The process is kind of I guess it's already been an hour now, and I just put it over here as well with the whole Google Docs as well. In order, if any particular person will go over the whole, just kind of watch the stream as well, I have put it over here in the Google Docs as well, and quite some force whenever you use it. Alright, so let's just come have a chat. Who's present right now? Who's watching the stream right now? If anybody wants to tell where they are from, right? Like it would be kind of an amazing thing. Who all people have connected is watching right now my stream. It kind of just motivates a lot. कोई बीच में गया था आज प्रदोष ये आज वक्त तो नहीं रखा है पूजा. You can follow the symbol GoFors as well as also some of the channels that has been that some of the videos that you might come across an amazing video just like all of them as well. All these particular the developer page as well as also the ambassadors and the software developers are doing pretty great in their role. So yeah. Right, so thanks a lot, and see you tomorrow. By the way, on 5th of January, we'll be having another live where we'll be discussing about the Rust programming language. So Rust and Golang usually fits together in a really perfect sort of a manner for any particular person who's been trying to build up architecture of the cloud architecture, building up certain kind of the softwares in order to provide power. They might use Golang in order to provide orchestrate the APIs and flow of traffic in a really perfect way. They might use Golang for the whole API architecture. But in order to build up that particular kind of an architecture, it will be an amazing thing to build the whole setup by Rust. So yeah, it can provide a lot transparency as well as also a lot more security to the environment. So yeah, that was all. Thanks a lot, and see you soon. Radhe Radhe. Jai Sri Ram.